Manta Ray.
Manta Ray.
Manta Ray project, the Manta Ray.
In an unexpected turn of events, a highly classified Navy drone that is owned by the United States has been spotted on Google Earth, alerting the defense community and capturing the attention of people worldwide. This shocking discovery of the top-secret underwater vehicle has sparked several speculation and curiosity, leaving the United States rivals in a state of unrest. What does this discovery mean for national security? Can this technology serve as the final line of defense in a full-scale nuclear conflict? Join us as we unveil the mystery surrounding the deployment of the top-secret Navy drone that was spotted on Google Earth. A top-secret U.S. submarine prototype known as the Manta Ray has been spotted by Google Maps users and is now visible to everyone online. Satellite images of this Star Wars-esque vessel docked at Port Hueneme Naval Base in California went viral on Sunday. Its unmistakable profile stood out against the other ships, capturing the attention of the internet public. The sleek, futuristic vessel, named Manta Ray for its smooth design and ability to anchor itself deep underwater, operates in low-power mode like its sea creature namesake. The Navy aircraft was created by Northrop Grumman for a U.S. Navy project aimed at developing long-range underwater weapons. This aviation company is well known for its groundbreaking projects, such as the world's first stealth bomber, the B-2 Spirit, and the ongoing development of America's new stealth bomber, the B-21 Raider. The B-2 Spirit, which is a pinnacle of aerospace engineering, was developed by the U.S. Air Force for deep penetration missions, capable of carrying nuclear and conventional payloads. Its distinctive flying wing design, which lacks a traditional fuselage and tail, enhances its stealth and aerodynamic efficiency. With a range of 6,000 nautical miles, the B-2 integrates advanced low-observable technologies, digital avionics, and a sophisticated fly-by-wire control system. Initially designed for Cold War nuclear strikes, the B-2 was later adapted for precision conventional attacks, featuring upgrades like GPS-aided targeting and the ability to carry up to 80 JDAMs. Its stealth capabilities are supported by radar-absorbent materials, low infrared and acoustic signatures, and strategic visual camouflage. Its construction involves carbon graphite composites and tight engineering tolerances, ensuring its radar-absorbent properties. It is maintained in specialized hangars to preserve its stealth features and remains a crucial component of modern military aviation. The B-21 Raider, on the other hand, represents a new era in strategic bombers for the U.S. Air Force, designed to replace older models with next-generation features. Developed under the Long-Range Strike Bomber program, the B-21 boasts advanced stealth capabilities, long-range endurance, and the ability to carry a variety of weapons, including nuclear bombs. It features innovative avionics, stealth technology, and a design optimized for radar evasion, using advanced materials and stealth coatings. It can carry over 30,000 pounds of various weapons, making it a formidable asset in modern warfare. The Air Force plans to acquire at least 100 Raiders, potentially increasing to 145. The Raider will initially operate alongside existing bombers like the B-52 and B-2, eventually replacing them. It will be stationed and maintained at multiple Air Force bases, including Ellsworth, which will be the first to host the new bomber. While many details about the B-21 remain classified, its capabilities have already troubled adversaries like China, sparking comparisons with China's Xi'an H-20 bomber. The B-21's design prioritizes stealth, advanced avionics, and communication systems, making it a central hub for modern combat operations. However, recently a different Northrop Grumman creation that is quite different from its exceptional bomber has been capturing attention online. This sleek, futuristic submarine combines the advanced technology seen in Northrop Grumman's stealth aircraft with the evolutionary prowess of the ocean's most graceful deep-sea predators. The result is a new deep-sea submersible designed to operate for extended periods in the ocean's depths, lying dormant on the seafloor until a threat approaches. The Manta Ray is a cutting-edge underwater drone. This sophisticated machine can hibernate on the ocean floor for extended periods without needing to refuel, making it a remarkable advancement in naval technology. Dr. Kyle Warner, Manta Ray program manager at the Defense Advanced Research Projects Agency, described the vessel's movement, stating that it makes use of efficient, buoyancy-driven gliding to move through the water. In an agency news release, he further announced that their successful, full-scale Manta Ray testing validates the vehicle's readiness to advance toward real-world operations. He went ahead to point out the aircraft's versatility, explaining that craft is designed with several payload bays of multiple sizes and types to enable a wide variety of naval mission sets. Its modular design allows it to be disassembled and transported in ordinary shipping containers, making it incredibly versatile and eliminating the need for specialized port facilities. According to the Telegraph, the Navy conducted extensive tests on the craft off the coast of Southern California, spending more than 3 months evaluating its capabilities. Defense analysts believe the Navy's push to develop drone technology is a strategic move to counter Russian and Chinese submarine operations. Russia has been advancing its own underwater drone technology, with plans to acquire nearly 3 dozen such vessels. The United States adversary claims their drone boasts a range of about 6,200 miles, can be armed with nuclear warheads, and can also reach exceptional speeds of up to 115 miles per hour. While nature's manta ray feeds on small fish and plankton, Northrop Grumman's manta ray targets much bigger prey, the nuclear ballistic missile submarines of enemy nations. These subs can sneak deep into American waters, posing a huge threat by potentially launching devastating attacks on the mainland. The manta ray is designed to counter these threats and protect American shores from a new nuclear conflict. The Manta Ray emerges as a stealthy underwater craft ready to confront submerged threats using a range of advanced capabilities before settling back on the seabed to patiently await its next mission. Northrop Grumman's unveiling of the Manta Ray uncrewed underwater vehicle on April 8 marks a significant accomplishment in deep-sea drone technology. This autonomous drone is built for long-range operations, capable of operating independently for extended periods with minimal human intervention, as outlined by Northrop Grumman and confirmed in Defense Advanced Research Projects Agency announcements and contracting documents. The journey began in March 2020 when DARPA awarded development contracts to Northrop Grumman, Lockheed Martin, and Navatech, marking a pivotal moment for their ambitious Manta Ray program. Dr. Kyle Warner, the program manager, envisioned an autonomous underwater vehicle capable of independent operations, self-sustaining energy harvesting, and completing assigned missions autonomously. Recent tests off the coast of Southern California in February and March 2024 showcased the Manta Ray's hydrodynamic prowess, affirming its ability to maneuver underwater using various propulsion and steering methods, buoyancy, propellers, and control surfaces. Dr. Warner emphasized the successful full-scale testing as validation of the vehicle's readiness for real-world missions, achieved through rapid development efforts. Chase boats closely monitored the performance assessments during testing, which lays emphasis on the program's commitment to fielding a deep-sea drone that is capable of extended operations without continuous human logistical support, as outlined in Dr. Warner's program description. While not explicitly detailed in the program's description, insights from those involved suggest that Manta Ray is focused not only on long-lasting deep-sea missions, but also on pioneering energy management and harvesting techniques tailored for deep ocean conditions. Essentially, it aims to find innovative ways to reduce energy usage and harness environmental sources to power the platform. This includes developing advanced systems on board to cut down on energy demands for everything from propulsion to detecting threats and more. Another company, Metron Incorporated, has also joined the effort to advance technologies in this particular direction. The goal of the program is to introduce a revolutionary underwater technology that moves away from the traditional torpedo-shaped military submarine design and embraces the streamlined forms seen in marine life. Although DARPA was open to designs that didn't mimic natural manta rays, Northrop Grumman seemed inspired by this concept when developing their own submersible. They opted for a sleek design resembling a manta ray with hints of the iconic B-2 Spirit aircraft. Dr. Warner noted that one can either chase them around with a host vessel, which is expensive and takes a lot of time and requires humans above them, or instead find a way to extend endurance under the sea. Part of this project from a military utility perspective is reducing the burden on human-operated ships. Also, mechanical engineer Dr. Jonathan Whiteham, who specializes in wave energy conversion at Sandia National Laboratories and serves as an advisor for the overall effort, says there are several potential avenues for power production under the sea beyond capturing the power of currents, such as salinity gradient power, derived in various ways like reversed electrodialysis. Northrop Grumman is digging into the concept of a limitless mission for their unmanned underwater vehicle station, involving the deployment of separate thermal energy pods. These pods generate electricity by tapping into the ocean's thermal gradients, using the temperature differences between warm and cold currents. For UUVs like Manta ray, these thermal energy pods could serve as underwater refueling stations, allowing them to return and recharge as needed. Communication poses another major problem for deep-sea platforms. While military vessels on or above the ocean surface rely on radio signals, these signals struggle to penetrate the ocean's highly conductive saltwater. American nuclear ballistic missile submarines heavily depend on very low-frequency transmissions, which are broadcast through large antenna complexes located at installations worldwide. These transmissions are crucial for maintaining communication with underwater assets. However, if these stations are compromised, maintaining this crucial link becomes extremely challenging. The thermal energy pod concept could also facilitate rapid data transfer. Data bubbles deployed from the energy pod could rise to the surface, where they would use internal RF satellite communications antennas to transmit data back to shore or nearby surface vessels. This innovative approach could ensure reliable communication, even if traditional means are disrupted. Navigating and controlling underwater, avoiding obstacles, and ensuring extreme reliability for extended operations in harsh environments are key challenges for the Manta ray project. If successfully addressed, these capabilities could profoundly enhance coastal defense strategies. The U.S. Navy is actively seeking such solutions due to the increasing array of submersible threats worldwide. Currently, Russia's ongoing production of 3 more Beret-class submarines and their development of the Status 6 Ocean Multipurpose System, also known as Poseidon or Canyon, are particularly concerning. This high-speed nuclear torpedo is designed to travel up to 5,400 nautical miles at speeds reaching 54 knots, which is about 62 miles per hour underwater, posing significant strategic challenges for maritime security. If a Russian Shchuka B-class attack submarine armed with long-range cruise missiles were to detonate inside an American harbor, the consequences would be catastrophic. This is not just a theoretical concern. Back in 2017, a Russian military documentary claimed that a fleet of these submarines positioned themselves just outside American waters. Detecting and tracking such submarines would not only reveal United States detection capabilities, but also potentially trigger increased investment by the Russian Navy into their own submarine fleet. The U.S. Navy responded swiftly to the Russian claims. In direct response to the revelations in the Russian documentary, then Secretary of the Navy Richard versus Spencer wasted no time in announcing the deployment of additional anti-submarine warfare assets. This move was aimed at bolstering America's defenses against potential threats lurking beneath the waves. Amidst China and Russia's aggressive advancements in undersea warfare capabilities, the United States and its NATO allies find themselves in a technological arms race. Initiatives such as DARPA's Anti-Submarine Warfare Continuous Trail Unmanned Vessel represent critical steps in countering these evolving submarine threats. Despite the vast array of warships and submarines at their disposal, maintaining a vigilant defense across expansive maritime territories requires constant innovation and unwavering readiness. Sea creatures, known for their natural ability to reproduce and adapt to their surroundings, are being studied to bolster sensor systems that monitor the movements of both manned and unmanned underwater vehicles. This initiative involves developing the necessary hardware, software, and algorithms to interpret animal behaviors into practical intelligence. Leveraging marine life for surveillance purposes could offer a cost-effective way to strengthen coastal defense capabilities. The threat posed by enemy submarines underscores the need for innovation. Each performer in the Manta Ray project has taken distinct approaches to addressing challenges related to the endurance of unmanned underwater vehicles. DARPA's goal is to tackle complex issues where there isn't a one-size-fits-all solution, ensuring resilient and versatile defense technologies for future needs. The United States is not the only nation with an exceptional submersible. Let's explore its rivals' intriguing deep-sea vehicle, beginning with Russia and China. Mir, which means world or peace in Russian, refers to a pair of advanced deep-sea vehicles. Originally developed by the USSR Academy of Sciences and the Lazuri Central Design Bureau, these vehicles were constructed by a Finnish company called Rauma Rapola's Oceanic subsidiary and delivered in 1987. The project was overseen by engineers from the Shirshov Institute of Oceanology. These vehicles were primarily designed for scientific research purposes. While they could potentially assist in submarine rescue operations, they cannot accommodate passengers underwater. The RV Academic Mstislav Keldysh serves as both the carrier and command center for Mir 1 and Mir 2, both operated by the Russian Academy of Sciences. Their military equivalents are the Konsul-class submersibles. Capable of diving to depths of up to 6,000 meters, Mir submersibles feature a personnel sphere made from a special miraging steel alloy. This alloy, containing cobalt, nickel, chrome, and titanium, offers a strength-to-weight ratio 10% better than titanium. The sphere's construction involves casting and machining two hemispheres that are bolted together, avoiding the use of welded joints. This design closely matches the density of water, aiding movement at various depths. Additional buoyancy is provided by 8 cubic meters of syntactic foam. Unlike other deep-sea vehicles using iron ballast, Mir adjusts its buoyancy and depth using ballast tanks. The Mir submersibles are formidable machines, measuring about 7.8 meters in length, 3.6 meters in width, and standing 3.0 meters tall, with a weight of 18,600 kilograms and a maximum payload capacity of 290 kilograms. The personnel sphere boasts walls that are 5 centimeters thick, encompassing a working area with a diameter of 2.1 meters. There are 3 viewports, one forward-facing with a 20-centimeter diameter and 2 side-facing with 12-centimeter diameters each. Powering these submersibles are Nikod batteries with a capacity of 100 kilowatt per hour. Electric motors drive hydraulic pumps that operate hydraulic manipulators and 3 propulsors, one aft propulsor rated at 9 kilowatt and 2 side propulsors rated at 2.5 kilowatt each. These capabilities enable the Mir submersibles to achieve a maximum underwater speed of 5 knots. Longitudinal trim control is facilitated by 2 spherical water ballast tanks located fore and aft. These tanks can expel water using compressed air as needed. Inside the cabin, air pressure is maintained at a constant 1 atmosphere, with air recycling akin to spacecraft operation, using lithium hydroxide scrubbers to remove carbon dioxide buildup. Communication with the surface is maintained via VHF radio, while imaging sonar units with a range of 250 meters allow for visualizing nearby objects and accurately measuring distances, including to the seabed during descent. The life support systems of the Mir submersibles can sustain operation for up to 246 man-hours, equivalent to approximately 3.42 days for a 3-person crew. Designed to withstand pressures at depths of 6,000 meters, these submersibles have been rigorously tested to 125% of that pressure. In actual field testing, Mir 1 descended to depths of 6,170 meters, while Mir 2 reached 6,120 meters. Originally equipped with hydraulic manipulators covered by helmet-like retractable see-through visors, these were removed during a major overhaul in 1994. Due to their operational constraints, the Mir submersibles change depths at a maximum vertical speed of 40 meters per minute, necessitating several hours for journeys to and from deep-sea sites. The Mir submersibles, initially developed by the USSR Academy of Sciences and Lazuri Central Design Bureau, were pivotal in various deep-sea explorations and film projects. In 1998, they were instrumental in documenting the sunken Japanese submarine 152 for a National Geographic special. Led by treasure seeker Paul Tidwell, the crew aboard the Russian RV Keldysh spent over 5 weeks in the mid-Atlantic, though no gold was recovered. These dives, reaching depths deeper than the Titanic wreck, were captured in the television special Search for the Submarine I-52. Later, the Mir vehicles were utilized by filmmaker James Cameron to film the Titanic wreck and the German battleship Bismarck for documentaries. They also played a crucial role in scientific missions, including the first manned descent to the seabed under the geographic North Pole in 2007, planting a titanium flag of Russia, and conducting research. In subsequent years, the Mir submersibles explored Lake Baikal and participated in scientific studies in Lake Geneva. Today, Mir Oni is displayed at the Museum of the World Ocean in Kaliningrad, while Mir 2 is housed at the Atlantic Division of Shirshov Institute of Oceanology in Kaliningrad, awaiting relocation to the Institute's museum in Moscow. Now, moving on to the Chinese Jiaolong. The Jiaolong, which means flood dragon in Chinese, is a crewed deep-sea research submersible capable of diving more than 7,000 meters deep. It was developed from the Seapole-class bathyscaphe and ranks second in depth capability among crewed research vehicles of the Chinese Navy. Only a few expeditions, such as those of the Trieste bathyscaphe in 1960 and the Deep-Sea Challenger in 2012, have gone deeper. The submersible was designed by Xu Qinan, a former professor at Shanghai Jiaotong University, known for his work in naval architecture and engineering. Xu, now an academician for the Chinese Academy of Engineering, led the design alongside his team, including Kui Weicheng and Zhu Weikung. Jiaolong made its first test dives in the South China Sea in 2010, reaching depths of over 3,000 meters with a crew of 3. It achieved deeper dives, including 4,027 meters in the northeastern Pacific in 2011, conducting extensive scientific research during its missions. In 2012, Jiaolong set a record by reaching over 7,000 meters in the Mariana Trench. Countries like the United States, France, Russia, India, and Japan have also developed advanced deep-sea technologies, reflecting the global interest and investment in deep-water exploration and research. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.